Hello pre-calculus students, and welcome to a video on interval notation and inequalities. Okay, hopefully you have a copy of the paper that we're going to go over right here. It's a one-page paper, and we're just going to fill out whatever's not filled out here. So first, a couple of main ideas here as far as the notation. So we have an open interval represented by parentheses that are curved, which is the same thing as an inequality that does not include the point, which is like saying there's no point there, and we call that non-inclusive. As opposed to a closed interval, which is the cornered brackets, which is less than or equal to and greater than or equal to. It looks like it didn't quite come out on the paper, but that's supposed to be less than or equal to, greater than or equal to, and then the closed hole, or the filled-in hole. Okay, so we're going to do this in the abstract first, which means I'm not giving you any numbers. I'm just saying x can be any number. A and b can be any numbers. We're assuming for these, we are going to assume that a is less than b. So we're assuming that these are not the same number, and it just kind of makes a little bit more sense here when we're talking about our two numbers a and b. Okay, so when we put our a and b on the number line, which I kind of like to do first in most cases, I know that x is more than a and less than b, so I'm just going to put like an a here, a b here, and since we have the including the point here, I'm going to put some filled in points. So I'm going to do my graphing in blue. So we've got a is included, b is included, they're both filled in, and everything in between. Okay, and as in interval notation, we would just say that's a to b. I meant to do that in black. A to b, and these are filled in, so we're including the endpoints, so we have the cornered brackets. Okay, and we call that inclusive. We use the word inclusive to indicate that we're including the endpoints. Okay, next one is an open interval, and this is also x is between a and b, so a is the smaller number, b is the larger number, and x is anywhere in between there. But this time, as we're reminded up here, when we have the absolute inequality, which means it does not include the endpoint, that's non-inclusive. We're going to have an open circle there, so that's the only difference between these two, these first two graphs. Open circle, make it really clear, really exaggerate that it's open so that there's no doubt when I'm grading it that it's open. And that is going to be the open interval from A to B, not including the endpoints, they're curved. Okay, then we've got something like a half open, half closed, so I'm going to put the A and B here on the graph first. And the A side is not included, so I'm going to put an open circle by the A. But the B side, we can see right here, is included, so I'm going to fill that one out. And I want to be very clear, again, just exaggerate that to be very clear, especially on a test or quiz, which one you're talking about. Now the open interval is on the left, so that's the curved one. That's the A. And the closed interval is on the right, and that's the bracketed one. Okay, then we've got sort of the simpler stuff that you learned way back when, but converting this to an interval, let's put the graph down first. So we just have one point here, so all we have is B, and this one is everything less than B, so I'm just going to put the open circle there, and everything this way, and put an arrow there so we know it continues. And then we have the next one is another B goes there. Let's just put in all of our B's. Okay, and the next one, x is greater than b. That means it's going to be an open circle also, but it is greater than. And then x is less than or equal to b, so this is going to be a closed circle at b, and it's less than or equal to b, and then greater than or equal to b. And as far as interval notation, when it's less than, the arrow here implies that it's going all the way to negative infinity. So when we make our interval notation, we use negative infinity, and we never count that as a number because it's not a number, so it's always open. So negative infinity up to b, and we're also not going to include b. And then this one, you can see from the graph that this is going towards positive infinity. So I always put the smaller number to the left, which is b in this case, and a larger number or concept, if in this case infinity is a concept, we're going to put that on the right. So it's going to go from b to infinity. Both of them are open, because this is an open interval. Okay, the next one is less than or equal to b, so it goes towards negative infinity as the smaller side, so that's always going to be open, because infinities are always open. And b is included, so this, as this solid point indicates, this is going to be bracketed. And again, if you just review these, when you have the solid point, it goes with the brackets and it goes with the inclusive, including the endpoint. So it's not just greater than, it's greater than and equal or equal to. Okay. So let's see, what was I going to do here? I was going to close the bracket for b because that is a closed interval on that side. Okay, and then the last one, it's going to go from b is the smallest point, and we're going to include that point, and then infinity, not really being a value, is not included, that's open. All real numbers, I usually just use some kind of a fancy R, so we can just, in an interval notation that goes from negative infinity to positive infinity, that's supposed to be an infinity, and on the number line, you pretty much just graph the whole thing, so you can just do something like that. Okay. Next one is the union of two intervals. Now remember, we're assuming here that for all of these problems, a is less than b, so it kind of makes sense here. X is less than a or greater than b. So let's put an a and a b on the graph, and a is less than b, so I'm going to put a over here, b over here. And on one side, we have x is less than a, so that's going to be an open interval at a. So I'm going to put the open circle to indicate that it's not counted, and everything less than goes to the left. And then also an open circle on the b side, and everything to the right. And as an interval notation, we're just going to put both. This is kind of a combination of two things from part 4 here. It's a combination of a and b. So I'm just going to put them both here with the word or between them, which means we're talking about the numbers on either of these one-sided intervals. So I'm just going to say that this is negative infinity to a, not including a, unioned with b to positive infinity, and not including either any endpoints here. Okay, and we do the same thing with the closed interval. Again, a is smaller, so I'm just going to put the a, whoops. So I'm just going to put the a down to the left and the b to the right. And these are closed, so I'm going to be very clear. I want everything. Oh, this is a little different now. This one is everything greater than a, so it's greater than the smaller number. So this is an intersection. So everything greater than the smaller number, so it goes this way. And everything less than b, so it's less than the larger number. And since this is an and, I want both parts here. So the real solution is going from here to here. And the blue just kind of helped us find it, but this is the solution, everything from a to b. So what that looks like in interval notation is it goes from a to b, and it includes both endpoints. Okay, a couple of examples. I'm going to suggest that you pause the video and see if you can work these out. You're given either interval notation or inequality notation, and just has to give the other and also put these on the number line. Okay, so the first one, interval notation is given, -2 to infinity. So now we're a little less abstract because we're working with numbers. On a number line, the only thing I need to put on that number line is the number that I'm given here, which is -2. And it's going to go, that's going to be the smallest, actually that's not going to count. This is an open interval, so I'm going to put an open circle there. And I want everything greater than -2, so it's going to just be like that. Interval notation is given. In inequality, this is just x is greater than -2. Okay, here we have x is less than or equal to 3. So let's put the 3 on the number line. That's really the only number that's important for graphing this. We're going to include the 3, so I'm going to clearly darken 3. And then I want everything less than the 3, so I'm going to go that way, and there's the graph. In interval notation, that is negative infinity up to 3, open on the left, closed on the right. Okay, next one goes from 2 to 4, so I need to put both of those numbers on my number line. And we are closed at 2, so I'm going to count the value at 2, so I'm going to make a nice dark circle there, and open at 4, so make it clearly open, and everything in between. As an inequality, oops, let's just do this in black. As an inequality, x is between 2 and 4. So I put that down there first. It's all the values between 2 and 4, including 2. So it's greater than or equal to 2, but not including 4. So it's an open interval on the 4 side. Okay, and then the last one, x is greater than 4. So we have a 4 and a 0. Let's put these in their right places. So 0 is lower than 4. And we have x is greater than 4, but not counting 4. So we have an open circle there. And x is less than 0, including 0, so we have a closed circle there. And it looks like that. There's 2 intervals that we're looking at, and we have to mention both of them, and we can just put the or between them, because it's not an overlap, or the union between them. So we have negative infinity to 0, including 0, unioned with 4 to infinity. Okay. Now the only other thing that I want to mention before we close this off is that this is more of an informal inequality notation, but there's also something called set notation. And I just want to show you that set notation is really very similar to inequality notation. Let's say, this one right here, we wanted to put that in set notation. Formal set notation uses brackets, like these fancy brackets, and you start out saying x, a slash, which means such that, and then x is less than or equal to 3. So all of these inequality notations can be easily converted to set notation. This just says the set of, and this says all x, and this says, we kind of read that as such that, and then x is less than or equal to 3. So I would read this as the set of x, set of all x's such that x is less than or equal to 3. But I'm not going to require that. I'm usually going to use interval notation in this class, and every once in a while inequalities, but very rarely will I use set notation. But you will see it occasionally on handouts, and you'll see it in the book when you use book problems. Okay, I hope you found this video helpful.